Welcome to all of you. In this video, we will be verifying the working of a NOT gate using multisim. So let us start with the selection of the component. So select TTL here. Then here is the list of components that we can select from various sources. So here is the listing. So we need to have a digital component. So select TTL, and in this we are going to have various listing. Let us first select 74LS, that's the usual series that we are going to make use of, and here are the various ICs available. See, this what the IC I selected, and this what the symbol what we can observe. So we need to have a inverter in this particular case. So we can just make a scroll down over here, corresponding symbol we can observe. Whichever we want we can select. Otherwise, if you know the IC number, that can be typed over here directly and we can have a selection of that. So let me scroll down. See, here is the IC that is NOT gate we have got. So let me select that and let us place that IC over here. So fine. So we need to have an input for that. Let us select source for that, input source. See, we can select either a power source and then we can provide a ground and all those things. So instead, let us consider the digital source directly, interactive digital constant, and then say OK, then place that over here. So in order to observe the output, we need to have some means. So let us select an LED for that purpose. So for that, again go here, select diodes. So within diode, make a selection of LED. So within that LED, so there are so many types. So we need to have an LED, something like this. So LED with blue color. This is what the indication of the blue color it is going to say, and green color, something like this. And to have a better view, let us consider the red color. So connected to the output side. So the other side of the LED has to be connected to the ground. So let us move back to the sources. There let us select power source. There select the ground. So this is what the ground we require. So say OK and connect the ground over here. So all the components that is required for us has already been connected. So let us close this window. So now we can just save this file or we can directly run. So let us first save this file. So let us save this as inverter. Right, so let us zoom it so for better visibility. Right, so we can just place this little left. Good. Okay, now let us run the simulation. So here is the run option we are having, or you can also make use of the function key F5. So let us run here. Right, so now here we can observe, see, input is 0. So because the inverter output will be 1, now LED is glowing. Now let us make a change. So just click over here, it will be changed to 1. So input is 1, so output is 0, so LED is turned off. Right, so make a verification once again. So now I will be just changing the input, 0, LED is turned on, LED is turned off. Right, so let us stop the simulation. So this is one way of verification. The another way of verification we can use here is making use of the digital probe. So let us select this digital probe and place it over here. Right, so now let me simulate, run it. Now input is 1, therefore output it is showing it as 0, LED is turned off. Now let us make a change over here. So input is 0, therefore output is 1, LED is turned on. Just make an observation. Right, so here what you can make the observation. So there is one more way of verification where we can make use of the oscilloscope. I will show that video I will show that details in the next video. Thanks for watching.